Welcome to this video lesson. In this video lesson, we will be introducing you to linear functions. Let's start off with a few terminology. So, the equation of a line connects the x and y coordinate of all the points on the line, meaning that it's a relationship for which if you put an x coordinate of a point, then you should be able to find a y coordinate of the point based on that relationship, or vice versa. If you put a y coordinate of the point, you should be able to get the x coordinate of the point. And this relation, you should be able to use this relationship or this equation to find all the points that lie on this line. Another big terminology that you need to know is what a function is. And what a function is, a function takes an input value or it takes another function, processes it using a set of rules, and then outputs another value or another function based on what the set of rules were. So let's give you an example to kind of solidify this idea. So in this example, we're going to take a function g of x, and we read this as g of x. And we're going to give it a set of rule, and the rule is going to be x plus 2. Let's break down what each individual part of this expression or this equation that we just wrote means. Okay, so the first part is actually the name of the function. So this means that we're talking about a function called g. What goes inside the brackets here is the input. So what input is it actually taking? And this is our input. The right hand of this equation over here, it's the rule associated with our function. So it's saying that whenever you input a value, whatever value x is, or you can enter a function instead of x, use this rule over here, x plus 2, and output something else. So here we're going to have a machine, and this machine is g of x is equal to x plus 2, and we are going to insert a value of x. Let's say we're going to insert a value of 1. And this x is equal to 1 is going to come into here. And this rule over here, which is g of x is equal to x plus 2, is going to insert the value of x is equal to 1 into this x value over here, get a final result, and output it as something. So what ends up happening inside the machine or inside the function is it says, oh, instead of x, we're entering a value of 1. And now instead of this x value over here, we are going to replace that with a 1. I'm going to write this as a 1. And we are going to add 2 to it. And what we get as a result is a 3. So our function will now output a value of 3. So it takes in, so looking at the definition again, the function takes an input value. In this case, our input value is 1, or a function, and we're not going to deal with a function for this set of lessons. Takes this value, processes it using a set of rules. In this case, the rule is g of x is equal to x plus 2, and outputs a value. In this case, once it adds 1 to 2, we get a 3. So it outputs this value 3. Now, you may ask, why do we need functions and why are they really useful? So it kind of relates back to the equation of the line. So in an equation of a line, we want some sort of relationship that will allow us to find all the coordinate points on the line. So by giving it an x value, for example, we should be able to find the y coordinate system of our point. So let's look at what a point is again. So here we have a point. This could be any point. Let's call it point A. And it will have an x coordinate and it will have a y coordinate. So it will have an x value and a y value. Now, we can assign our function to the y value. So we can say that, let's use the color purple here, y is equal to, let's use the example we just did, g of x, and our g of x was equal to x plus 2, meaning we're gonna, let's say, we're gonna do the example right here. So this is going to represent g of x, this graph over here. So it's gonna have a y value and it's going to have an x value. So let's create our machine again. Here is g of x. And it is going to intake a value, and we can give it any value that we want. So let's give it a value of 1. And as we saw before, it will, once we give it a 1, it will give a value of 3 out. So our input, which is our x value for point A, is 1, and our y value ends up being 3. So then we can go ahead in our graph and actually start from the origin right here and move 1 to the right for our x and move up by 3 for our y, and that will represent one of the points in our graph over here. So let's actually write x here, and here y is equal to g of x, and the set of rules that we had for g of x again is x plus 2. So we can write a continuation here and say g of x is equal to x plus 2. So given that our x value is 1, our y value is equal to 1 plus 2, the 1 being this value over here, x, and our y value will equal to 1 plus 2, which is equal to 3. And this gives us a point 1, 3 on the graph. Let's insert a few other points. So this relationship or this equation that we have, y is equal to g of x or y is equal to x plus 2, should give us all the points. So we can take 10,000 points, we can get 3 points, we can take 4 points. We need at least 2 points to really represent this line. So let's take a point 0, for example. Point 0 is going to give me y is equal to, so y is equal to, instead of x, I'm going to replace it with a 0, and then I'm going to add 2 to that. I'm going to get 0 plus 2 is equal to 2. So my new coordinate has an x value of 0 and a y value of 2. So I get 0 and I get 2. So to graph this, what I will do is I will go 0 on my x, so I'm not moving in this direction, but I'm going up by 2. So I'm going to put a point right here at 2. I can take a few other values before connecting my line, and I can take any x value, so it doesn't really matter what it is. So I'm going to try to plug in a x value of -5 into my function. And now I will take -5 for my x, add 2 to it, I will get -3, and this means that my x value is -5 and my y value is -3. So on my graph, I'm going to go 1, 2, 3, 4, 5 to the left, and 1, 2, 3 down for my y value. So it will be a point right here. Let's take one other point and make sure that it will be on the line. And I am going to choose a point, let's say 7. So now I'm just going to write the equation down here so you can see it once again. So I'm entering G7. So instead of x, I will put in 7, and I will still have 2, and this will equal to 9. So I get 7 plus 2 is equal to 9, and my x coordinate is 7, and my y coordinate is 9. So I can now plot this point. I go right on the x-axis by 7, and I will go up by 9. And I should get a point over here. And now I'm just going to connect all the lines. Let's use a different color. Let's just use green over here. And if I connect the lines, I will get something like this. And whenever you're drawing a line, again, try your best to use the whole graph. You don't want to draw a line very small like this. It's not very meaningful. Try to use as much of the graph as possible. And I have correctly here labeled my y-axis and the x-axis. So based on the relationship of, or our function of g of x, which is equal to x plus 2, we have assigned our y-coordinate to this function, and what this function has done is it has taken any x values that we have given it, and based on that gave us the y-coordinate of our graph. And since I've drawn my graph, I should also label it. In this graph over here, you can either label it as g of x, because you know that y is equal to g of x, or you can label it as y is equal to x plus 2. Now let's use another example, and I'm going to use another linear relation. And what I'm going to do is actually I'm going to erase everything that we've done so far, and I'm just going to leave this x and y, and we're going to use a different function. Let's use another function. Let's call it let's call it f of x. So our function f, which is dependent on x value here, and we're going to assign our y value to be f of x, and let's use negative 2x plus 3. So once again, we're assigning our function, or this whole thing that takes the x values to give us an output, to our y, and we do that because we want to insert an x coordinate value and get a y coordinate value based on that. And our relationship is negative 2x plus 3, and so this is the rule that is applied to our function. So let's put a few values in. First, I'm going to start my set of data over here. So I'm going to write x here. I'm going to write y is equal to f of x. And just to be a little bit more clear, my f of x is negative 2x plus 3. I am going to choose a few x values. I'm not going to choose too many. Let's just use 4. Let's use negative 3. I like negative 1. It's easy to calculate. It's easy to do. 0 is very easy, usually 1. And let's choose one more actually. Let's choose 5 as well. And again, these values, it doesn't really matter what x coordinate you're choosing. You could actually use a half. You could use 0.2222 if you wanted to, because the whole point of this equation of the line, or this function, is to take any value that you have, any x coordinates, and give you the y coordinate of the point that lies in the graph. So let's do the calculations on the left hand side of the screen over here. So I'm going to use purple, and for my x value of negative 3, my y will equal to f of negative 3, and that means I'm going to write everything down here, except instead of x, I'm going to substitute value of negative 3. So this is going to be negative 2 times negative 3 plus 3. Negative 2 times negative 3 gives me positive 6. Add 3 to it, and I get 9. So that means my first point for x is equal to negative 3, y is 9. Let's do my next one. Actually, here we go. For x value of negative 1, y is equal to f of negative 1. And that means negative 2. Instead of x, I'm going to insert negative 1, add 3, and I get negative 2 times negative 1 is positive 2 plus 3, and I should get 5. So for x value of negative 1, my y value is positive 5. Let's do another example. X is 0. That means y is equal to f of 0, negative 2 times 0. And I like 0 again because whenever you multiply 0 by anything, you just get 0. So this means when my x value is 0, my y value is 3. So a few points here that I got. One is x is negative 3, y is 9. Here x is negative 1, y is 5. Here x is 0 and y is 3. Let's do the last point too. And let's just do the point 1 and then we'll write what the value for y value for 5 is as well. When x is 1, y is equal to f of 1. Instead of x, we are plugging in positive 1, adding 3 to it, and I get negative 2 plus 3, which is equal to positive 1. So my point here, when x is 1, y is 1. So my coordinate point is 1 and 1. So here at negative 3, I got 9. I got 5 here, I got 3 here, I got 1 here. And for 5, I'll just do 5 here. Negative 2 times 5 plus 3, which is equal to negative 10 plus 3, which is equal to negative 7. So plotting all my points here, I have a point over here as negative 3, 9, negative 1, 5, 0, 3, 1, 1, and 5 and negative 7. So let's plot those into this graph, and I get negative 3 and positive 9, 1, 2, 3, 9, and my next point is negative 1 and positive 5. And my next one is 0 and 3, and my next one is 1 and 1, and my next one, or my final one, is 5 and negative 7. 1, 4, 5, 1, 2, 3, 4, 5, 6, and negative 7. And I am going to connect this all using blue line. And I am going to put the arrows here, meaning that my line continues forever. And you can see that this one has a negative correlation, so as my independent variables are increasing, my dependent variables are actually decreasing, versus the old one, or the first graph, g of x, where when my x values or my independent variable was increasing, my dependent was actually increasing. So it does have the opposite steepness in this case. And I am going to label this as y is equal to f of x, or y is equal to negative 2x plus 3. And it doesn't matter which one you label it as long as you have mentioned it. Or if you are labeling it as y is equal to f of x, just make sure somewhere in your page you have defined what f of x is. In this case, f of x is defined here as negative 2x plus 3, so it's completely valid. The only other thing I have forgotten in this graph is to label the points. Here is x and here is my y-axis. So in summary, in this lesson we've learned how to use a function or an equation of a line to plot the different points, to kind of make a table of values, and based on that find the points of our line and to finally plot them using the previous lesson, which was coordinate geometry, in order to actually draw our line. So let's do one final example here. Use the equation y is equal to negative x plus 1 to draw the graph below. So we're trying to draw this relationship right here. Here, there's no mention of a function. Here we're just saying y is equal to negative x plus 1. Really, here is kind of the rules that apply to our function. If we want, we can give this a function, let's say f of x, and f of x in this case is simply negative x plus 1. We don't have to in this case, so we will start making a table. Here is x, here is y is equal to negative x plus 1. And I'll just make this a little bit bigger. And actually, I'm going to keep it the same size just so that if you have this much space, I'll show you how to do the working. I'm going to choose a few values over here. I am going to choose, let's say, negative 4 as my x value. I'm going to choose negative 1, 0, and let's say, let's do 10. So for the first one over here, usually when you're doing a question like this, make sure to choose some x values. Some really good x values to choose often are 0. 0 is always one of the best ones. Usually negative 1 and positive 1. Positive 1 is a little bit better, but we're going to practice with negatives a little bit in this lesson. And sometimes fractions are good to choose, sometimes they're not good. Sometimes it's good to use even numbers or numbers that are being multiplied by the denominator of the coefficient of x. But in this case, we'll just use these values. Any values are valid as long as you have proper mathematical procedures. Okay, let's use purple. So for the first one, I am inputting a value of negative 4 into my equation. So I get y is equal to negative. Instead of my x, I'm going to replace it with negative 4 plus 1. This negative and negative make it positive, so I get 4 plus 1 is equal to 5. So for negative 4, my y value is 5. So my first points on the graph will be negative 4 and 5. Let's put that on the graph, y, x, and we go left by 4 and we go up by 5. So a point right here. I am going to actually label this as negative 4, 5. You don't have to, but it's nice at the beginning when you're just getting used to plotting points to put the coordinates down so that you kind of have a better understanding. Later on, as you get better, you can kind of skip this step. For my next point, I'm going to use a different color so you can see a little bit better. For the negative one, I'm going to do y is equal to, and I'm still using this equation over here. So y is equal to negative, and instead of the x, I'm going to plug in negative 1. So I'm going to go negative, negative 1 plus 1. Negative and negative make it positive, plus 1, and I get 2. And my second point is -1 for x and +2 for y. So I go left by 1 and up by 2, and my point is -1, 2. And I should write that down here. My third point, let's use green for this one, is y equals to -0 plus 1. -0 is just 0, plus 1 is just 1. So I get a value of 1 here. So my third point is going to be 0, 1. And I'm going to plot that right here, and I'm going to label it as 0, 1. Finally, for the last one, let's just use black. I get 10, so my equation is y is equal to -10 plus 1. So I get -10 plus 1, which is -9. So my final point here has x coordinate of 10 and y coordinate of -9. So I have to move right by 10. So that's like this point, and then go down by 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So right here. And this point over here is positive 10 and -9. And I will connect all these points. Let's use blue. And it will look something like this. And I'm going to put the arrows. And I will put down my equation here. Y is equal to -x plus 1. Just to check to see what concepts should I include when I am using an equation to draw a graph, and if I'm using table of values, I would have to have a table. And all the values here should be accurate. I should show 3 sample calculations. Actually, 2 sample calculations are often enough. So at least 2 sample calculations. So here for method and accuracy, and method and accuracy for 2 sample calculations. And in my graph, I'm going to make sure that I have labeled the axes, that I have labeled my equation, that I have my points. I don't have to have, so these are the points, so the accuracy for points. And I don't have to have all the coordinates, but the points must be there. I should have a line connecting it, and I should have my arrows at the end.